Hello students, we are solving the IB Math AA AGL past paper questions and currently we are solving the IB Math AA AGL May 2023 paper 2 TZ1 past paper. Today we will be solving the question number 11, that is the second last question of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring classes. So without any further delay, let us start solving question number 11. The maximum mark is 19. A continuous random variable x has a probability density function defined by f of x equal to 6 over pi times square root of 16 minus x squared for x values ranging between 0 and 2. X is greater than or equal to 0 but is less than or equal to 2. And f of x is having a value of 0 for every other value of x. Okay. So part A's question is find the exact value of E of x. That is the expected value of x or the mean value of x. Okay. Fine, and it is containing 5 marks. It is, you have to get the exact value. So even though it is a paper 2, we cannot use the calculator. Okay. And let me just write the formula for the expected value. It is in the formula booklet. This is negative infinity to positive infinity x times f of x dx. Okay. But for this question, f of x is having some non-zero expression only for x values lying between 0 and 2, both included. So these limits should get changed from negative infinity to positive infinity. This should get changed to from 0 to 2. Okay. So part A, this is from 0 to 2, 6 over this and times by x, because it is x times f of x. So the numerator will be 6x over pi square root of 16 minus x square dx. Okay. And I am taking out the 6 over pi portion. It is just the coefficient. 0 to 2x over square root of 16 minus x square dx. Okay. And okay, let me do the substitution part over here because I have to substitute. So let t is equal to 16 minus x square. So dt over dx will be equal to negative 2x, and therefore dt over negative 2x will be equal to dx. Okay, and since I'm substituting, I have to change the limits of integration as well. So I'm making this table. First is 0 and then it is 2. When x equal to 0, I'm taking this equation, t equal to 16 minus x square. When x equal to 0, 16 minus 0 square is 16. So t is equal to 16. And when x equal to 2, 16 minus 2 square, 2 square is 4, 16 minus 4 is 12. So that t's value will be equal to 12. Okay. So this should be equal to 6 over pi, and the lower limit will be 16, the upper limit will be 12, and it is x over root t, and in place of dx, it is dt over negative 2x. And these two will be getting cancelled. So we have, I can take out this 2. That means I'm taking out the half because 2 is in the denominator. And we are seeing there is this negative sign. And we know this property of definite integral. If this is a to b, f of x dx, this should be equal to negative b to a f of x dx. Okay. And usually we have the upper number more than the lower number. But in this case, the 12 is less than 16. So I just want to get this 16 at the top and bring this 12 down. That is why I am using this minus sign. Okay, I'm taking this minus sign, so, and I'm bringing this 2 outside. So it is 6 over half times, 6 over pi times half, and this is 12 to 16, and this is dt over. Now, we don't have any place for radicals in calculus, so I have to express root t in terms of some exponent, some power of t, which is t to the power of half. Okay. So these will be getting cancelled, and I will be having 3 over pi, and it is 12 to 16. I'm bringing this part to the numerator, so it is t to the power of negative half dt, which is 3 over pi. Negative half plus 1 is positive half, so it is t to the power of half divided by half from 12 to 16. Okay, and divided by half is multiplied by 2. So 3 over pi times 2. I'm taking this outside this bracketed part because this will not be contributing. This half will not change its value according to the limits. Okay, so I'm taking this half outside, divided by half, so it is multiplied with 2. So 3 times 2 is 6. So it will be 6 over pi, and this will be 16 to the power of half minus 12 to the power of half. Okay. So this is equal to 6 over pi, and 16 to the power of half is square root of 16, which is 4. Okay. 4 minus 12 to the power of half. What is 12? It is 3 times 4, which is 3 times 2 square. So 12, 3 times 2 square raised to the power of half. So 3 to the power of half is root 3, and 2 square root of 2 square is 2. So this part is 2 root 3. Okay. This part will be giving me 2, and this 3 raised to the power of half is root 3. So it is basically 2 root 3. Okay. So this is the exact value of the expected value of x, or the mean value of x. Okay. You can, if you want, you can take out one of the 2's, and this can be written as 6 times 2 will be equal to 12 over pi, and this will be 2 minus root 3. You can write this also as the final answer. Okay. Fine. So we have solved subpart A. Coming to subpart B. Okay, let me solve the subpart B over here. P of x less than 0.5. P of x less than 0.5 should be equal to, again, the x values are between 0 and 2. So the limits will be from 0 to 0.5. Because it is a continuous variable, the less than or less than equal to, they don't have any difference. So the limits will be from 0 to 0.5, and this will be taken as the integrand. So it is 6 over pi square root of 16 minus x square dx. Okay. It is containing just 2 marks. Okay. We have given this integration. We can solve this without the help of GDC also, but since it is containing 2 marks, I feel that we can safely use the GDC. Okay, because we have written this expression will be giving us 1 mark, and the final answer will be giving us the 2nd mark. Okay, but for that we have to write using GDC. Calculus. So let me take the GDC, and it is calculus over here and numerical integral. Okay, and the limits will be 0 and I can go to this place. Okay. It is 6 over pi times square root of 16 minus x square. Okay, and I come to this part, x, and I have to move to the left. Yeah, it is 0.5. Fine. 6 and pi, and this is fine. So enter. 0.23938 up to 3 significant figures, it is 0.239. Okay. P of x less than 0.5 is equal to 0.239. Correct? To 3 significant figures. Okay. Fine, we have answered part B. A laboratory trial may require up to 2 milliliters of reagent. The amount of reagent used has been found to have a probability distribution that can be modeled by this f of x, where x is the amount of reagent in milliliters. Okay. And each laboratory trial is independent. Okay. And a trial is considered a success when x is less than 0.5. X is the amount of reagent needed in milliliters. When x is less than 0.5, it is considered to be a success. So there will be two outcomes. A success whenever, as soon as we are reading the term success, you should be thinking about, obviously, the only other thing that is possible is the failure. So we are having only two outcomes. Okay. One is the success, another is the failure. So we are given that the trials are independent and we are knowing that we are having two outcomes. One is the success, another is the failure. And they are saying that, so Parsi's question, determine the least number of trials required to be 99% sure of at least one success. Okay. So we are knowing that there are two outcomes. So binary, the trials are independent and minimum least number of trials. So the number of trials will be constant. So that also indicates the binomial distribution. Number of trials fixed. Each trial is independent. Probability of success is constant. And you have two outcomes. One is the success, another is the failure. So we can take a binomial distribution variable to represent this situation. Okay. So let me write this C parts answer over here. Okay. So let at least one success. So let y represents the number of successes. Okay. Therefore, y is a binomial distribution variable. We do not know what is the number of trials. We have to find the least number of trials. So it is n. I'm keeping the number of trials as n. And the probability of success is, a trial is considered a success when x is less than 0.5. So what is the probability of success? We have found the probability of success when x is less than 0.5. That is in subpart B. So what is the answer for the subpart B? It is 0.239. You can take more number of digits for the probability of success. I can take more number of digits because I now need, I am going to some other calculation. So let me take 0.23936. Okay, I'm taking 2 more digits. So I'm adding 3 and 6 because it is 358. So I'm adding 3, 6. Okay. So I'm taking the probability of success as 2.3936. Fine. And we have to find that there is at least one success. Therefore, probability of y, at least one success means we can have one success, we can have 2 successes, we can have multiple successes. The minimum is we will be having one success, right? So it will be y is greater than or equal to 1. Okay. This should be greater than or equal to 99% sure. So expressed in decimal is 0.99. Okay. And how do we get this? Because even though we are having the calculator, since we do not know the value of n, that is what we have to find. We cannot use the calculator. Okay. So whenever you have at least one success, you have to think about what are the conditions that are left out. Because we can have one success, we can have 2 successes, we can have 3 successes, we can have multiple successes. So the only one condition that we are not taking is not having any success. That is the only one condition which is getting left out. Okay. So this can be written as 1 minus, because the sum total of all the probabilities will be equal to 1. So probability of y greater than or equal to 1 will be equal to 1 minus the probability of 0 successes. Okay. That means y is equal to 0. Okay. And this should be greater than or equal to 0.99. Clear? Fine. And so what is this equal to? How to write this inequality? Because this part I cannot enter in the calculator. But we know the expression for the binomial distribution. So what is it? If you have suppose x is a binomial distribution variable, and you have n, and you have n is the number of trials and p is the probability of success, then probability of getting x equal to r, that means probability of having r successes, is equal to, is given by NCR, and probability of a success is p. So p to the power of r, p to the power of r, and probability of failure will be 1 minus p, because there are only 2 outcomes, either a success or a failure, and the sum total of these 2 outcomes will be equal to 1, sum total of the 2 probabilities. So if the probability of success is p, then the probability of failure has to be 1 minus p. Therefore, the 1 minus p, that is the probability of failure, should be getting raised to the power of n minus r. So this is the expression. Okay, if x is a binomial distribution variable with n number of trials and p is the probability of success, then getting r successes, probability of getting r successes is given by this expression. Okay, so now we come to this relation. Over here we are having 0 successes and the number of trials is n, and the probability of success, that is p, is equal to this. Okay, so I can write it this inequality in the form 1 minus, it is NCR. Now R is what? This is x equal to r and that is y equal to 0. So the r's value is 0. So I am taking NC0. P, that is the probability of success, which is this in our case, 0.23936 to the power of r. So it is 0. And 1 minus p, which is 1 minus 0.23936 to the power of n minus r, that is n minus 0, which is n. Okay. And this should be greater than or equal to 0.98. Clear? Now, what is NC0? If I try to find the NC0, what is the expression for NCR? It is n factorial over r factorial times n minus r factorial. Sorry. Okay. So nc0 will be equal to n factorial over 0 factorial because r is 0 and n minus 0 factorial which is n factorial. Okay, and these two will be getting cancelled and we will be having 1 in the numerator and 0 factorial is 1. So 1 over 1 is equal to 1. So nc0 is 1 and anything raised to the power of 0 is also equal to 1. Okay, so this is nothing but 1 minus 0.23936 to the power of n is greater than or equal to 0.99. Okay, now we are having the calculator. Of course, we will be using the calculator and I always prefer the graphs. You can use the nsolve as well, but if you use the nsolve, you have to take the equality side. Okay, but I will be using the graphs. So I can go to this part and I can take the graphs. Okay, so I'll be drawing two graphs, one for the left hand expression and this will be y equals 0.99, a horizontal line. Okay, so it will be 1 minus 0.23936 raised to the power of, I'm taking x, okay, because I'm graphing I have to take the x. This is the graph and I have to draw a horizontal line y equals 0.99, so it is 0.99, enter. Okay, let me change the settings, window settings. I come to this place and I'm seeing it is on the right hand side of the y-axis. So I am keeping the x min as -1 and x max, I can keep it as 50. Let me keep it as 50. I don't know where will they be intersecting. And then I can come to this part. Y min also, it is above the x-axis. So I can keep y min as -1 and y max, it is y equal to 0.99, so very close to 1. Let me keep it as 1.5. Okay, and yes, I have pressed the OK. Fine. So we are seeing this is the graph, the blue colored one and this red colored horizontal line, and we are seeing initially the blue one is below the red one because this should be greater than, therefore this blue colored graph should be above the horizontal line, red horizontal line. Okay, so over here initially we are seeing that the blue one is below the red one, so we have to find the point of intersection. So analyze graph and intersection, and where are they intersecting? Over here. Okay, so when x equal to 16.83 to 1, and of course the y value has to be 0.99. These two graphs are intersecting, and after this x value, the blue colored graph is going above the red colored horizontal line. Okay. So therefore, this value of x, we will be taking this value of x 16.8321, or this will be the n value, and we have to take all the x values which are more than 16.8321, because when x equal to 16.831, they are just meeting, they are intersecting, so they are at the same place. After 16.831, the blue colored one is moving up above the red one. Okay, so n value should be more than or equal to 16.8 because they have included the they have included the equality sign. So I have to give the answer as n is greater than or equal to 16.8321. Okay, so therefore using GDC graphs, n is greater than or equal to 16.8321. Let me check once more. Okay, 16.8321. Yes. But n is the number of trials. N cannot be a decimal number. It should be a positive integer. Okay. So I have to take n greater than 16.8321. Therefore, since n should be a positive integer, therefore, n is equal to 17. They have asked for the least value of n, least number of trials, okay? Because I can give the n value as 18, 17, 18, 19, all of them are above 16.8321. But I had to give the smallest value. So this will be our answer for the subpart C. Okay. 10 trials were conducted. Subpart D's question is find the probability that exactly 3 trials were successful. And we had found that the probability of success was 0.23936. Okay. We have taken 5 decimal places. So find the, let me write the D's answer over here. Okay. And let me take, say, again, I'm taking Y. So binomial distribution variable, this time we know the value of n, that is 10, and the probability of success is 0.23936. Okay, and they are asking that exactly 3 trials were successful. So we have to find P of Y equal to 3. And it is containing 2 marks. Okay, fine. We'll be using the calculator, of course. So we can go to this part and we have to go to the probability and then distribution, and then we have to use, it is the binomials and it is Y equals 3. So you can use the binomial PDF or you can use the binomial CDF. I'm seeing the binomial PDF. Let me try the binomial PDF. So number of trials n is 10. And then the probability of success is 0.23936 and X value is 3. And it is okay. It is 0.24235 and all up to 3 significant figures. So let me write using GDC binom PDF and 10.0. Okay, let me just copy it. Using GDC, because it is containing 2 marks, it is better to write this. Binom PDF. It is 10 and then it was probability of success 0.23936 and then the X value was 3. This is equal to 0.242. I'm taking after 3 significant figures, okay? Equal to 0.242. Correct to 3 significant figures. Okay? Sapati. Write down the number of ways these 3 successful trials could have occurred consecutively. Number of ways. Okay, it is containing just a single mark. Okay, fine. So I can write the answer of Sapat E over here. There are 10 trials. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 3 consecutive successes. So let us take these 3 successes. The remaining ones are the failures. And the 3 successes that we are having, they should be consecutive. So I'm taking the first 3 trials as the first 3 successes as the only 3 successes consecutive. Next option is this one. Third is, so it is 3. 4, 5, 6, 7, and 8. Okay, so the answer is 8 ways. Fine. Now consider in trials where it is given that exactly 3 successes have occurred. We are not given the value of n, but we are said that exactly 3 successes have occurred. And if it is also containing through 2 further subparts, write down an expression, the first subpart of subpart F is saying write down an expression for the number of ways these 3 successful trials could have occurred consecutively. We have seen when the total number of trials is 10, the number of ways of getting 3 successful trials, consecutive 3 successful trials is 8. Okay, so we do not know what is the value of n, but we have to give the answer. So it is better, we are seeing when it is 10, when the number of trials is 10, the number of ways is 8. So 10 minus 2. But let us be sure of this expression, whether it will be n minus 2 or not. Okay. I'm taking the number of trials as 5. Okay. So 1, 2, 3, 4, 5, and this is 5 trials. So 3 consecutive successes and only 3 successes. So it can be 1, it can be 2, and it can be 3. Okay. So 3 ways. Even now, if you are not confirmed, let me take 8 trials, because if I take 7, you'll be saying, why are you taking both 2 of them as odd number of trials? Let me take 8 trials, okay? So it is 1, 2, 3, 4, 5, 6, 7, and 8. So 1, 2, 3, 4, 5, 6. Again, 8 minus 2. So 6 ways, okay? So therefore, for n trials, it is n minus 2. Okay. N minus 2 ways. Okay. So this is the answer for the first subpart. Okay. Coming to the second subpart, the last subpart of this question. Find the greatest value of n such that the probability of 3 consecutive successful trials is more than 0.05. First, they have said exactly 3 successes are happening. And then they are asking us to give the greatest value of n, highest value of n, such that the probability of 3 consecutive successful trials is more than 0.05. So whenever you are having one condition given, because initially they have specified that exactly 3 successes have occurred. That means they have given a condition. We cannot take 2 successes, we cannot take 4 successes, we have to take exactly 3 successes. So that is a condition that has been provided. And now they are coming to the 3 consecutive successes. Okay. If you are having, say, 5 trials, then we are saying we can have 3 consecutive successes. But we can have, say, this is a success, this is a failure, this is a success, this is a failure, and this is a success. Even over here, you are having 3 successes, but these 3 are not consecutive successes. So we can have more number of ways in 5 trials in order to have 3 successes. What will be the probability? it will be, we will be selecting from 5, we will be selecting 3 of them. So it is 5C3. We can have 3 successes in 5C3 ways. Okay. It is just a combination. We are selecting out of 5 trials. We have to select 3. 3 successes will be taking place. So that is just 5C3. But now we are just narrowing by imposing another additional restriction that those 3 successes should be consecutive successes. When we are imposing another additional constraint, then we are having for 5 trials, it is only 3 ways. Okay. So originally one condition has been given and now they have imposed another condition. So this is a conditional probability. Okay. We are saying that 3 successes are happening. Given that 3 successes are happening, what is the probability of having 3 consecutive successes when the number of trials is n? And what is the maximum value of it? That is the question. Okay. So it is F and II. I am taking number of trials equal to n. Okay. They have given the number of trials as n, so I have taken the same thing. Okay. And it is the probability, it is the conditional probability. 3 consecutive successes given that 3 successes are there and exactly 3 successes are there. Okay. So this is the conditional probability. Now, if we take the 3 successes, let this be the universal set. There are n trials and there may be different number of successes, and this may be the set of 3 successes. Okay. They may be consecutive, they may not be consecutive. And we are seeing that in the case of 5 trials, we have seen that if we consider 3 consecutive successes, there are only 3 ways. But if we take 3 successes, consecutive or non-consecutive, doesn't matter. We are having more number of ways because this is one of the ways that I have written. Okay, I could have taken S, S, F, and then F, and then S. That is also another way of getting 3 successes, but not 3 consecutive successes. So the number of ways in which we can get 3 successes in number of trials, let that be denoted by this set, circular one, circle. And the number of ways in getting 3 consecutive successes will be lesser, obviously, because this is 3 consecutive successes is only 3. But 3 successes will be more than 3. The number will be definitely more than 3. It is 5C3 ways. Okay. So you have to just calculate what is 5C3. If I just do the working over here, it is 3 and this is 2. So this will be 5 times 4 times 3 factorial. This 3 factorial and that 3 factorial will be cancelling and you will be having 5 times 4 over 2. So it is 10 ways. So getting 3 successes in 5 trials, you can get them 3 successes in 10 ways. But getting 3 consecutive successes in 5 trials will be only 3. So always when you have 3 successes in number of trials, the number of options that you will be having, and if you impose another condition that you are taking only 3 consecutive successes, the number of options that you will be having will be definitely less than the number of options that you had previously. That is when you have considered only 3 successes, both consecutive and non-consecutive. Okay. Therefore, this 3 consecutive successes will be a subset of 3 successes because 3 successes will be an addition of 3 consecutive successes and non-consecutive successes. So the 3 consecutive successes will be a subset of 3 successes. So the value will be smaller. It is just a subset. Okay. So what will be the formula? It is for conditional probability P of A given that B has occurred. It is P of A intersection B over P of B. Right. And now we are seeing, since it is a subset, therefore P of 3 consecutive successes and 3 successes is equivalent to P of 3 consecutive successes. Okay. So this is P of 3 consecutive successes over P of 3 successes. Clear? Now, what is the probability of having 3 consecutive successes in n trials? Okay. So, I'm taking, first of all, I'm considering a single case where we are having 3 consecutive successes, and I cannot draw n number of trials. I have to take a finite number. I'm taking 5. Okay? 1, 2, 3, 4, 5. So, I'm just taking this part. The first 3 trials are successes. So, they are one of the options of having 3 consecutive successes. So, what will be the probability? Probability of a success or getting one success is 0.23936. Okay. So, getting 3 consecutive successes, I will be writing this as 0.23936 whole raised to the power of 3, because it will be 0.23936 times 0.23936 times 0.23936. And for these two, it will be the probability of failure. That means 1 minus 0.23936 to the power of, this will be 1 minus 0.23936 times 1 minus 0.23936. So times by 2, not times by to the power of 2. Okay. So this is one condition when we are having these first three trials as the 3 consecutive successes. And how many ways can we have 3 consecutive successes in 5 trials? It is 3 ways. So this is just one condition. I have to multiply this with 3 because this will be the same. The probability will be the same. If I take 1, 2, 3, 4, 5, and if I take these 3 as 3 successes, again these 3 will be contributing to this part, and these 2 will be contributing to this part. Okay. So for every possibility, we will be having this product. And how many options are we having? 3 options. So this will get multiplied by 3. Clear? When it is 5 trials, but this time it is just n trials and not 5 trials. And we have seen that number of ways that we can have 3 consecutive successes when we are having n number of trials is n minus 2 ways. Okay. So this is just the rough working. For this, it is n minus 2 ways, because I'm just like I had multiplied with 3 because there were 3 ways. Over here for n trials, there will be n minus 2 ways. So I'm multiplying n minus 2. Okay. And there are 3 successes. So it will be this part, 0.23936 to the power of 3, because 3 successes. And how many failures are over here? I have taken 2 because 5 minus 3 is 2. This 2 I'm getting from this subtraction operation. For this case, for our case, when the number of trials is n, it will be n minus 3. So number of failures, the probability of failure is 1 minus 0.23936 to the power of n minus 3. Okay. So this is the numerator. Fine. Now coming to the probability of 3 successes. Just like for the 5 trials, how to get the probability of 3 successes, how many ways can we have 3 successes out of 5 trials? It was 5 C3 ways. Okay. So how many ways can we have 3 successes in number of trials? It will be in C3 out of the in trials that are available. There will be 3 successes. I'll be selecting 3 trials randomly. Okay. Out of the in trials that are given to us. So it will be in C3 ways. Therefore, in C3, you can write this as in C3 as well. Okay. They mean the same. So it is in C3. And then again, this part will be the same because there are 3 successes. So it will be 0.23936 to the power of 3. And there will be n minus 3 failures. So it will be 1 minus 0.23936 to the power of n minus 3. So I can cancel these two. Okay. And this should be greater than 0.05. Clear? So it is n minus 2 over NC3. Let me just solve this NC3 separately. NC3 is n factorial over 3 factorial and n minus 3 factorial. Okay. So this can be written as n minus 1, n minus 2, n minus 2 it is. Okay. Over 3 factorial is 6. 3 times 2 times 1 is 6. Because n minus 3 factorial and n minus 3 factorial, those will be cancelling each other. Okay. So it is the denominator will be n times n minus 1 times n minus 2 over 6. So I can write this as 6 is going up over n times n minus 1 times n minus 2 is greater than 0.05. And I can cancel these two. So this is 6 over n and n minus 1 is greater than 0.05. Okay. I'm not simplifying this inequality any further. I can again use the graph. And again, I'm saying you can use nsol. So I go to the graph. Okay. And I'll be taking this part. So it is 6 over x times x minus 1 and enter. Fine. Good looking. And I have to take 0.05. 0.05. Okay. Enter. So I am changing the settings. Definitely I have to change the settings. So menu and then settings and let the x min and x max stay, and this can be 0 and this can be 0.5. Okay. Fine. I have to change the x settings as well, I'm seeing. So I can take the window settings x as negative 30. I have no idea, to 30. Let's see. Yeah, it's working. This part should be above the horizontal line. See, this part is the pink colored graph is above the horizontal line in this portion. I can get the coordinates of the intersection points. So this is the first intersection points coordinates, and in will be the n is the number of trials. So n cannot be a positive, n cannot be a negative integer. I'm not getting the coordinates of this intersection point because this is towards the left side of the y-axis. So the n value will be, or the x value will be negative. We cannot have n value as a negative number. So I will be taking this value. Okay. So using GDC graphs, n is, it should be greater than 0 and it is less than 11.4659. 11.4659. It should be greater than 0 because y-axis there, x equal to 0 is the vertical asymptote. Okay. And I'm seeing x equal to 1 is also another vertical asymptote. So we are having two vertical asymptotes. And this is the y-axis. So I'll be having x equal to 1 as another vertical asymptote. So it should be greater than 1. This is not, I'm not taking from 0, between 0 and 1. I am not taking that portion. And over here, I am seeing the pink colored graph is above the green colored line. So it is more than 1, but it is less than 11.4659. So the largest value, the maximum value of n that can be taken is equal to 11. Okay. Therefore, n is equal to 11. So we have completed answering this question number 11. Thank you for staying with me till the end. I am Nilanjana Sanyal. I am an online IB Math ASL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. In case you have liked my explanation, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching my video. And in case you have not subscribed to my YouTube channel till now, please subscribe to my channel. It will be motivating me to make more math videos for you. I'll be understanding, I'll be knowing that I'm being able to help you. So that will be my motivation. And we meet again very soon in our next session. We'll be solving the last question of the same paper. Till then, bye.